Let me check if it's working. Hello.
Everyone was live.
Yeah, it's definitely working. كيف بحط how do I put the chat outside? Hey, Clipper. Oh. Okay. I'll just wait for people to join. بعدين شو الوضع. Let's just wait a little bit for people to join. Hello, we're just waiting for people to join. شباب بس عندي سؤال how do I put the chat لبرا كده خليني افتح الهون والله بس بدون صوت. I will just check the chat. Bro, is anyone here? Guys, if you're here, can you just tell me? عشان I can start. Okay, so I'm just gonna start. لحظة. Wait, لحظة. How do I mute? How do I mute? It's from here? Okay. So now I'm gonna. Okay, so first I'm gonna cover the topic of بسم الله الرحمن الرحيم. I'm gonna cover the topic تبع PV equals nRT, these stuff, because I'm gonna start like basic. Wait, can you guys hear me? Let me check. So. Okay. So let's get started. Just a second. Okay, I'm getting everything ready. Okay. Just a second. So you guys, I'm شوي wasting you guys time, but just deal with me. Okay. طيب here. Okay, so first I'll start. Obviously we're gonna have the ideal gas laws. طيب. طبعا you guys know ideal gases, they obey the law which is PV. Okay. They obey the law PV equals N شو R في T. Okay. And then you guys obviously مش obviously really بس انه طيب let's شوي go back, you know, and recap this. So what do we say when we have thermodynamics? It's all the particles, okay? If you have a closed chamber, it's the particles that are inside that chamber. Meaning by, if I have, let's say like this, whatever, that many particles, we are studying these particles that are inside that closed system, chamber, whatever, okay? So just a second, guys. Okay, yeah, so as I was saying, yeah, so we're studying all of these particles inside that closed container. So let's see what happens. Okay, so first I'm gonna start by saying in moles are, and I have a notebook in front of me, so I'm just trying to like بلخص كل شيء. So moles are molecules over Avogadro's constant. هذا جميل. Okay, so the moles are molecules over Avogadro's constant. Okay, that's the first that's the first rule. طيب. And then obviously we have those other rules which are like P1 V1 equals P2 V2. Also we have P1 over T1 equals P2 over T2. We also have instead of these ones, the V1s are T1 or T2. Oh, we also have we have P1 V1 over T1 is P2 V2 over a T2. Okay, طيب. Now we get to a really important factor. Okay. طيب. When dealing with all these these particles and stuff, obviously logically يعني it's gonna have a velocity. Okay, we call this velocity the root mean square. Okay, it's just always like this. Let me just خليها v أحسن. The root mean square. Okay, طيب. A formula of it is the energy kinetic of these particles, okay, is what is half الماس في الروت squared. طيب. فشو هي what it basically is. طيب. It's like it's a three-dimensional velocity. اوكي y z و x. طيب obviously v of x و v of z و v of شو y. if you're trying to measure one of them, okay, here it's always gonna be انه cx or sorry اللي هو ال vx equals ال vy equals ال شو ال vz. طيب as we said, if you square it all, since they're all equal, تمام, so I'm gonna say انه sum total squared equals sum cx squared plus sum, why do I keep writing c? sum ال vx squared plus sum ال vy squared plus vz squared. Okay, but since they're all equal, you can say انه these يعني it's gonna be شو one of the components squared. يا أخي why do I keep writing c? equals 1 over 3 ال total root mean square velocity. Okay, this is one of the important rules. طيب then we have a really important rule that requires derivation, which is p equals 1 over 3 n times m times ال v squared over ال volume. طيب where does it come from? Okay, because they could require you to derive it. طيب we obviously know انه ال f is the change in momentum over شو the change in time. طيب but obviously since it's a closed container, so change of time is going to be time. طيب what is momentum? Momentum is mv, so it's going to be m delta اللي هي ال v, صح؟ صح, over التايم. حلو. طيب بعدين you guys also know that, okay, I just want you to imagine like having this container, okay, this particle is coming like this, بعدين it goes back, okay, so it covers the two of the length divided by the velocity, because that's the time. V equals sorry, x equals vt, so the time is the position over the velocity. So the position is L, is 2L, okay? So the time here is gonna be so m delta Vx over 2L over هاي ال Vx, okay? طيب using شوية algebra, تمام, بس wait, here, تمام, I did something شوية, here it should be 2m Vx. Why? Because when we have a momentum, sorry, here it's gonna be mv final minus v initial, yes, but the v initial is gonna be in opposite direction, so it doubles. Okay, ال 2 مع 2 راحت, bring this guy up, so it's gonna be the force is your mass في velocity squared over length. طيب the force total obviously for all particles is what is the entire molecules multiplied by the mass multiplied by the velocity as it is squared. It's the same formula بس with the n. طيب بعدين if you want the pressure, and pressure is the force by the area over the n m vx squared over the area. okay, هي شوف هي هنا بتكون L times the area L squared, صح؟ it's gonna be n m Vx squared over شو over الفوليوم because L times L squared is شو الفوليوم. اوكي طبعا احنا as you remember I told you ان Vx squared is 1/3 ال V total squared. So we're gonna substitute that, so it's gonna be 1/3 N M Vx squared over the volume. That's how you calculate that formula. Okay. حبيبي جميل حبيبي. طيب. So that's like a simple derivation because they require you to get it. Okay. Then obviously other equations are in energy kinetic is 3/2 kT. What is the K? It's Boltzmann's constant. طيب, which can be calculated by it is R over NA. It is Boltzmann's constant. طيب. Let me see what else I have. Okay, so I have also another gas law which is PV equals N في K في T, number of molecules into Boltzmann's constant into the temperature. طيب. Let's move a little bit to to the important thermodynamics. طيب. So we got طيب, yeah. Okay, so we're gonna go to the U equals Q plus W. What is this? طيب. U هي internal energy. Okay. Internal يعني we can say total. Q هي heat. تمام. W هي work done. تمام. One of the formulas for the work, okay, طبعا work done by the gas يعني please يعني تمام. We're talking about gas. For work done is شو P delta volume. Okay. Okay. Let's see what else we got. Okay, so another important note in the work can either be positive or can be negative. So positive could be negative. When the work is done, when work is done on the gas, it's positive. When the work is done by the gas, it's negative. تمام. هنا الفوليوم decreases, okay, وهنا الفوليوم increases. تمام. بعدين a diagram you're gonna see a lot is this. Let's see. Pressure against volume diagram cycle. طيب. This is very important. From X to Y, طيب, no change in this is pressure. Okay, so it's gonna be no change in volume. So let me close this stupid thing. So the work done is 0. Okay, I have it's memorization, please. From Y to Z, volume increases, so it's a negative work, so it's by شوفها by negative. طيب. From Z to X, تمام, الvolume decreases, you can see. Oh, sorry, and I didn't even write the. Okay, sorry. Oh my God, sorry. So from X to Y, no change of volume work is 0. From Y to Z, volume increases. So from Z to X, volume decreases. It's a positive work. It's on the gas. طيب. Really important note as well. And delta U through one cycle is always equals to 0. تمام. really important rule. Capacitors وكده و electric field I don't think I need to really go into it into that depth that much, so I believe really that's it. Okay, I believe people have problems with this, so yeah. Okay, let's check if there's anything.